Alright, let's take a look at lesson 8.1, Angles of Polygons. Make sure that you have your new note packet out, and at the very top you want to make sure that you've written down the title of today's lesson, 8.1, Angles of Polygons. Alright, our learning target, we are going to find the sum of the interior and exterior angles of polygons and use those sums to solve problems. Here are some of the main ideas. Let's fill in the blanks together. A polygon is a closed figure formed by three or more line segments called sides. Up to this point, the only polygons we've been dealing with are triangles, but now as you can see as you look down the page, we're going to deal with polygons that have 4, 5, 6, 7, maybe 17 sides. And then finally, here's a lengthy explanation of what is meant by the sum of interior angle measures. Now, we know that the sum of the interior angles in a triangle is 180. But what happens when there's 4 sides, or 5 sides, or 6 sides? Do they all add up to 180? We're going to find that out. Here it says the sum of the measures of the interior angles in any polygon can be determined by the number of triangles, I would underline that can be drawn within the polygon, specifically when you draw diagonals from one vertex to another. It says complete the table below and look for a pattern to find the sum of the degrees in any polygon. So let's begin our table. We'll begin with the easiest, a triangle. Within this triangle, we know that there are 3 sides and that is a single triangle. We also know that the sum of the interior angles in a triangle is 180 degrees. However, what happens when we have a quadrilateral? That would be 4 sides, or a pentagon, or a heptagon. Here's what you notice. In each of these diagrams, what they've done is they've chosen a single vertex, and from that vertex they've drawn all the diagonals they can to any other vertices. In this case, you can only draw one diagonal. Here, they could draw 2 diagonals. Here, they could draw 3 diagonals. And when you do that, you can see the number of triangles that are formed. So let's begin with this. A quadrilateral has 4 sides, and we can even go down the rest of the column here, right? A pentagon has 5 sides, a hexagon has 6 sides, right? What you'll notice, though, is when you start to draw these diagonals, you split your polygon into multiple triangles, right? We see 2 triangles here. We see 1, 2, 3 triangles here. And we see 1, 2, 3, 4 triangles here. Now, one of the things you may notice, look at the relationship between these numbers. 3, 1, 4, 2, 5, 3, 6, 4. You'll notice that to get from one to the other, you can simply subtract 2. So imagine taking the number of sides, subtracting 2, and you get the number of triangles. It works on each and every one of these, which will help us with the examples below where there's no diagram. Now, how can we work from the number of triangles to the sum of the interior angles? Well, we know that inside a triangle, the sum of the interior angles is 180 for a triangle. Well, consider, if a quadrilateral is made up of 2 triangles, if you simply take 2 and multiply by 180, you would get 360. The same, of course, holds true for this first line, right? Since there's one triangle, multiplying by 180 gives you a sum of 180 degrees. So in order to figure out the sum of the interior angles for any polygon, you take the number of sides, subtract 2 from it, and then multiply by 180. If we continue this process, 3 times 180 will give us 540 degrees for the sum of the interior angles of a pentagon. For a hexagon, when we multiply by 180, we're going to get 720 degrees. As we continue this table, right, you'll notice that the diagrams disappear, but we can still work with it. Now, you might not be familiar with the prefix hepta, but that means 7. 7 sides. Octagon is 8 sides. Nonagon is 9 sides. Decagon is 10 sides. And even though we don't have a diagram, we know from the relationship earlier that the number of triangles present in a heptagon when you draw all the diagonals will be 7 minus 2, or 5. Same thing here, subtract 2, there are going to be 6 triangles here. Subtract 2, there will be 7 triangles here. Subtract 2, there will be 8 triangles here. And then to find the sum of the interior angles, just take each of those numbers of triangles and multiply by 180 degrees, since the sum of the interior angles in a triangle is 180. And here's what we get. 5 times 180 leaves us with 900 degrees. 6 times 180 gives us 1,080 degrees. 7 times 180 gives us 1,260 degrees. And finally, 8 times 180 gives us 1,440 degrees. So let's summarize what we just demonstrated in this table as a formula. So down below it says if n represents the number of sides of a polygon, then the sum of the interior angles, okay, so sum is represented by capital S, can be found using the following formula. So S for sum equals, and then we'll do parentheses. Remember what we did first. We took the number of sides and subtracted 2, and then after doing that, we multiplied by 180. So this is describing exactly what we just discovered using our table. Take the number of sides, subtract 2, multiply that by 180, and that gives you the sum of the interior angles within any polygon. So let's look at the next couple of examples. In example 1, right, it says find the sum of the measures of the interior angles in a 15-gon, right? That just means a polygon with 15 sides. So that just means S equals 15 minus 2 times 180. Well, that's just 13 times 180, which equals 2,340 degrees. Make sure you put degrees. For a 21-gon, right? S equals 21 minus 2 times 180. Well, that's 19 times 180, which leaves us with 3,420 degrees. And there's 2 more examples here. You can try them on your own, but we don't need to see 2 more to understand that idea. Let's go ahead and take a look at the definition of what's called a regular polygon. You'll want to fill this in on your notes. A regular polygon is a polygon in which all side measures are congruent. Therefore, all angle measures are congruent. So this is important, right? For regular polygons, all side measures are congruent. Therefore, all angle measures are congruent. The measure of a single interior angle in a regular polygon can be found by dividing the sum of the interior angles, S, by the number of sides, N. Here's a great example. What is a regular quadrilateral? Think about that for a moment. A regular quadrilateral, a 4-sided shape where all sides and angles are congruent. Well, now that I've drawn it, you probably have a pretty good idea. That is a square. From our chart earlier, we know that the sum of the interior angles in a square is 360 degrees. And if I wanted to know how big is an individual angle in this regular polygon, I would take the sum, 360, and divide by the number of sides, or the number of angles, which is 4. And that gives me 90 degrees. Now, of course, I knew that for squares, but this just demonstrates that this holds true. So let's try examples 5 and 6. Here it says find the measure of each interior angle of the following polygons. It says regular pentagon and regular 18-gon. Now, a reminder, a pentagon has 5 sides. So first thing we'll need to do is find our sum. S equals, right, parentheses 5 minus 2 times 180. Well, that gives us, let's see, 3 times 180, which gives us 540 degrees. Now, that is the sum of all the interior angles. But if I want to figure out the measure of each individual angle in a regular pentagon, I need to take S, the sum of all the angles, and divide by N, the number of sides, or the number of angles. In this case, that would be taking 540 and dividing by 5. And when you do that, you get 108 degrees. Okay, now let's try example 6. This time they want us to find the measure of each interior angle in a regular 18-gon. So first, we need to find that sum of all the interior angles. S equals, parentheses, 18 minus 2 times 180, right? That would be 16 times 180, which gives you a sum of 2,880 degrees. Keep in mind that's just your sum, not our final answer. To find the measure of each interior angle in a regular 18-gon, just like before, we need to take our sum and divide by the number of sides, or the number of angles. In this case, take 2,880 and divide by 18. And if you do that, you're going to find that each interior angle will measure 160 degrees. All right, we've been focusing a lot on the interior angles of these polygons. Now let's take a look at the exterior angles. What happens if we add up what are called the exterior angles? So a reminder, exterior angles are supplementary to their adjacent interior angle. Remember, supplementary means they add up to 180. It says find the measure of each exterior angle on the polygons below, then give the sum of all the exterior angles. Well, this isn't too tricky as we consider these two angles. They should add up to 180. So if this is 61, this would be 119. If this angle right here is 79, subtract that from 180, this gives you 101 degrees. And if this angle right here is 40, subtracting from 180 would give you 140. What happens if you add 119 plus 101 plus 140? Well, you get 360 degrees. The question is, that's what happened with a triangle. What happens with a quadrilateral, or a pentagon, or a hexagon? Well, let's do this real quick. If we find each of these exterior angles, I'll help you fill them in quickly. This one would be 109. This one right here would be 56 degrees. This one over here would be 104. And this one right here would be 91 degrees. Notice these are called exterior angles because they're along the outside. They're formed by extending one of the edges of our polygon. If we add up all of those numbers, guess what we get? 360 again. Let's try it again. Maybe it's a fluke. This one up here, right, is 82 degrees. Over here, we get 59 degrees. Down here, we're going to get 93 degrees. Over here, we'll get 50 degrees. And finally, over here, we're going to get 76 degrees. Guess what? If you pause and add all those up in your calculator, you are also going to get 360. Let's just check it with hexagon as well. Right, we'll get 65 degrees here. We'll get 51 right here. 56 in this corner. Then we're going to get 68 right here. In this bottom corner here, we'll have 57. And then right over here, we're going to have 63. And you guessed it, if we add up all of those, we get 360 every single time. So let's summarize this. I think they ask for a conclusion here. What can you conclude about the sum of the exterior angles, of the exterior angle measures of a polygon? Let's fill in this together. The sum of the exterior angles of any polygon is 360 degrees. So make sure you've written that down before you move on to this next bit of the video. All right, now let's do some practice with exterior angles. In example 7, it says, what is the measure of each exterior angle of a regular hexagon? Notice they're not asking for the sum here, they're asking for the measure of each exterior angle of a regular hexagon. Well, we know the sum of all the exterior angles is 360, and if we divide it up evenly among the 6 sides in a hexagon, that means that each exterior angle would be 60 degrees. In example 8, it says, what is the measure of each exterior angle of a regular 24gon? We can do the same thing. We know that all the exterior angles add up to 360. Divided equally among 24 angles will give us 15 degrees for the measure of each of those exterior angles. In number 9, it says, if the exterior angle of a regular polygon measures 12 degrees, how many sides does the polygon have? Well, think about the approach we just took earlier, right? We took 360, we divided by n, that would be the number of sides, and that gave us each individual angle measure. Okay? If 360 divided by n gives us each individual angle measure, couldn't we flip-flop these, right? Just as 360 divided by 6 gives us 60, couldn't we also say that 360 divided by 60 gives us 6? These two can flip, just as these two can flip. We've seen this before. So I can take 360 degrees, divide by 12 degrees, and say, how many 12-degree angles are there in 360 degrees? And if we do that, we're going to get 30. That would be 30 sides. 30 times 12 gives us 360, meaning there are 30 12-degree angles in 360. In the same way, we can approach number 10, right? It says if the exterior angle of a regular polygon measures 40 degrees, how many sides does it have? Well, take 360, divide up 40. How many 40s fit in 360? Well, there's 9. So that tells us that there are 9 sides on that polygon. All right, moving on then. Let's summarize all the formulas that we've discussed, because it's been a lot of information so far. Let's begin with the very first one that we summarized, right? The sum of the interior angle measures. If you remember, that was capital S is equal to parentheses n minus 2 times 180. That's the first one that we generated using our table. Then the sum of the exterior angle measures. If you remember, that one isn't really a formula at all. It's just memorizing. It's 360 every time. Then if we want to find the interior angle measure of a regular polygon, right? Basically, we're taking S and dividing by N. If you want to write it in a more detailed way, we can write the formula for S. Remember, that was N minus 2 times 180, all divided by N. So this is kind of the simplified version. This is the more specific version that shows one formula inside of the other. Now to find the exterior angle measure of a regular polygon, we showed that earlier. We take 360 and we divide by the number of sides. And then for this last one, if we want to know the number of sides and we're given the measure of each exterior angle, we saw that with our last two examples, you would take 360 and you would divide by, I don't really have a variable for it, but you would divide by the exterior angle measure. So if you take 360, divide by the exterior angle measure, that will tell you how many sides there are in that regular polygon. All right, now that we've summarized those formulas, let's put them into practice by looking at a few examples. In example 1, it says, what is the sum of the measures of the interior angles of a pentagon? Pentagon means 5 sides. Okay, that was our first formula. So S equals 5 minus 2 times 180. Well, that would be 3 times 180, which is equal to 540 degrees. Number 2, same kind of question, but this time it says, what is the sum of the measures of the interior angles of a 27-gon? So we use the same formula, S equals 27 minus 2 times 180. Well, that gives us 25 times 180, and that should give us quite a lot, 4,500 degrees. As we look at number 3, look carefully at the directions. What is the measure of each interior angle of a regular octagon? If you remember to figure this out, it's interior and they want us to find each. So this is S divided by N. So we'll use our formula for the sum. S equals parentheses 8 minus 2 times 180. And I'll save you some space. That's 6 times 180, which gives you 1,080 degrees. 1,080 degrees. Now that's S, but it's not our final answer. To get our final answer, we need to take S and divide by N. So in this case, 1,080 divided by the number of sides, which is 8, and we find that the measure of each interior angle in a regular octagon to be 135 degrees. Let's try the same thing for number 4. In number 4 it says, what is the measure of each interior angle of a regular 20-gon? Okay, so if we do that, we use our S formula. S equals parentheses 20 minus 2 times 180. Well, that would be 18 times 180, and I can save you the time on that. That should give you 3,240 degrees. That's our value for S, but remember, they're not asking for S. They're asking for the measure of each interior angle. So to find our answer, we need to take S, that is 3,240, divide by the number of sides. In this case, that's 20. And if we do that, we find the measure of each angle is 162 degrees. Okay, let's look at number 5. Number 5 says that there are 5 angles of a hexagon, and they give us some of their measures, right? 119, 129, 104, 139, 95. Now you'll notice a hexagon has 6 sides and 6 angles. They only give us the measures for 5 of them, and it asks what is the measure of the 6th angle. Well, first thing we should probably figure out is what should the 6 angles in a hexagon, what should their measures add up to? So let's find S. S equals, in this case, 6 minus 2 times 180. Well, that would be 4 times 180. Let's see, which gives us 720. All the angles inside a hexagon should add up to give us 720. So if we want to figure out how much is missing, right, they've only given us 1, 2, 3, 4, 5 angle measures. All we need to do is take 720 and subtract away all the ones they gave us. Subtract away 119, subtract away 129, and 104, and 139, and 95. And let's see what's left. When you do that, you'll be left with 134 degrees. So that final angle that is not given to us must have a measure of 134 degrees. All right, let's take a look at number 6. In number 6, it says the sum of the interior angles of a polygon is 1,620. How many sides does the polygon have? I would like for you to put a star next to number 6. This is the kind of question that I see many a student miss because they go through it too quickly. Let's begin by just copying down the formula for the sum of the interior angles. It is S equals parentheses n minus 2 times 180. And up until now, you have been provided with the number of sides and you have been asked for the sum of the interior angles. However, number 6 flips this around. Instead of providing you with n and asking you to find s, this time they provide you with s and ask you to find n. So let's go ahead and substitute in. Instead of saying s equals all of this, we're going to say 1,620 equals all of this, n minus 2 times 180. And all we need to do now is to solve for n. Well, the first thing I should probably do is get rid of this multiplication by 180. So let's divide both sides of the equation by 180. And when we do that, we end up with something that says this. 9, right, 1,620 divided by 180 gives us 9 equals n minus 2. Many students pause at this point. They think, oh, I just need to divide by 180 and that's my answer. Except take a look. Have we solved for n yet? No. We have to add 2 to both sides in order to isolate n. N equals 11 in this case, which means this polygon has 11 sides. So be really careful. You're undoing the formula, and there were 2 operations in there. We undo the multiplication of 180 by dividing by 180, and we undo the subtraction of 2 by adding 2. We have to undo both of those operations to get our answer. All right, continuing on then, let's take a look at number 7. In number 7, it says the sum of the interior angles of a polygon is 3,960 degrees. How many sides does the polygon have? Well, this is the same kind of question, right? A reminder, our formula is S equals n minus 2 times 180. So let's go ahead and substitute for S. S in this case is 3,960. That's equal to n minus 2 times 180. Just like before, we're going to divide both sides of the equation by 180, but we're not going to stop there. When we divide them by 180, we'll be left with 22 is equal to n minus 2. To get n by itself, don't forget to add 2 to both sides. Often students forget that. And we find that n equals 24, which means that this polygon has 24 sides. All right, continuing on, in example 8, it says, what is the sum of the measures of the exterior angles of a nonagon? Well, a nonagon has 9 sides, but honestly, it doesn't matter how many sides it has, because remember, when you're talking about the sum of all the exterior angles, there's no formula. The sum of all the exterior angles in any polygon is always 360. No work necessary. Now, number 9 asks, what is the measure of each exterior angle of a regular 20gon? Regular means all the angles and sides are congruent, so we need to take the sum of all the exterior angles, 360, and then divide by the number of sides or the number of angles. So we take 360 and divide by 20. That tells us that the measure of each exterior angle is 18 degrees. If 360 degrees is split up into 20 equal angles, each angle will be 18 degrees.